What is up? This is Ozarka again, and we're basically going to be doing more problems of solving. This time we're going to be solving absolute value equations and inequalities. You can kind of see on this document right here, it says the two objectives here, so we're going to be solving those absolute value of equations and inequalities here. But before we do that, it's probably a good idea to review what the absolute value is even all about. So first thing here, it says the absolute value of a number, so I'm just reading this right here, is the number's distance from zero on the number line. Okay, that's one way to think of it. So if you think of like, I don't know, a number like 5 is 5 units away from zero. Okay, but also -5 is also 5 units away from zero. So it's basically that distance. Another way of thinking about it is it's always the positive value. If the number is actually negative, the absolute value of it's always going to be positive, or it could be zero as well. But the moral of the story is it cannot be negative. Okay, the absolute value basically makes any value that's inside of that absolute value positive. Unless it's zero, then it just stays zero, but it never is negative. Another way of thinking about it is what's written right here. The absolute value of x is equal to x if x itself is positive or zero. Okay, I kind of already said that. Or it's equal to negative x, think the opposite of x, if x is negative. Okay, so the absolute value, whatever's inside of that, could be positive or negative because the absolute value is just going to take care of it anyway. And we're going to basically use that yellow and green line there to be solving basically the equations and inequalities in this video. So hopefully this will make more sense once we see some examples. All right, next thing it says, based on the definition of absolute value, it should be clear that, okay, we kind of already said this, the absolute value of x is either equal to x or negative x, depending on whichever is positive. If we're not sure which is positive, we must consider both options. So you're going to see those both options characteristic taken into account. Here is that example similar to what I just was talking about a second ago. If the absolute value of x is equal to 5, then x must either be 5 or -5. And you can kind of imagine that in your head if you actually just wrote this down and did the absolute value of 5 and the absolute value of -5. Okay? No matter what you put in there, you are going to get 5 out of it. So when you are solving for whatever is inside the absolute value, you have to take into account the positive version of it and the negative version of it in order to get the final answer. If you just do one of them, you're not going to get the full answer. You'll maybe get half the answer, but you need to do both. Absolute value equations. So it says right here, suppose p is positive or 0. The absolute value of x is equal to p is simply a compound equation in disguise. So it's almost like a piecewise equation if you want to think of it that way as well. But it's basically like two problems in one, essentially what's written right here. And then it's got, I don't know, a step-by-step process right here to solve an absolute value equation. There's these 3 steps here. Use algebra to write the equation in the form of this right here. In the context, x and p may be entire algebraic expressions, but the equation can only make sense if p is greater than or equal to 0. So that's again going back to the absolute value definition. Then you're going to solve it in 2 different ways, where x is equal to p and -p, and then always make sure you check your answers because sometimes you get an answer and it doesn't actually work out. And I'm going to kind of talk about that in a second. One thing that is really important to point out is if you have the absolute value bar, if you have the absolute value of some variable, I'm actually just going to write it here. Let's just say x, just to be simple, and it's equal to something that's negative. Let's just say -3. This is impossible. Okay, you cannot take the absolute value of something and get a negative out of it. Okay, so whenever that happens, you're going to want to write no solution, and we're going to be showing a specific example that's like this as we go through this video. So hopefully that makes more sense as we go. All right, onward to some examples. All right, this first one here, it says solve for x, and it says the absolute value of 2x plus 4 is equal to 8. So just like I said before, we're going to basically be splitting this into 2 different problems. We're going to be splitting it into 2x plus 4 equals +8, and then also splitting it into 2x plus 4 equals -8. Okay, we're going to solve for x for both of these equations, and then we're going to check our work, throwing it back into the original equation just to make sure that it checks out, and then we should be good to go. So first thing we're going to do here is subtract 4 on both sides. So the 4 is going to be gone on that left. I'm going to subtract the 4 here, so you're going to have 4 over there. Okay. From here, we're going to divide both sides by 2, and you're going to end up with x equals 2. So that's one of the equations, and if you plug in 2 back into this original thing, you're going to get 4 plus 4. The absolute value of that is 8, so that does check out. All right, so I'm actually just going to highlight this as one of the answers. All right. The next one, same thing. I'm going to subtract 4 on both sides. So you're going to get 2x equals negative 12. And then from here, I'm going to divide both sides by 2, and you're going to get x is equal to negative 6. Again, plug it back up in here, and it's going to be negative 12 plus 4, which is negative 8. The absolute value is equal to 8. So that actually does check out as well. And then we have those two numbers as the answer. Now, that's kind of just like a warm-up problem here. What I recommend doing for the other problems is actually, like, again, I kind of talked about this in the last video, but just like trying to solve it out. Like, so pause the video, try to solve out number 2, and then once you have the answer, press play. Or if you hit a roadblock, you can press play again after you pause it. But again, it just kind of helps get you to know how to do this on your own, which is the whole goal of this. Anyone can kind of watch me do it and make sense of it, but to actually do it on your own, make sure you get the right answer is it's key. So I would advise doing that. So yeah, pause here, try to solve number 2, and then press play and see if you did it right. Otherwise, I'm going to go right now. First thing I'm going to do on this is, if you notice, it's got an absolute value bar right here, around that W minus 7. But there's this other stuff. There's that plus 2 and that negative 5. What you're going to want to do is get number 2 when a problem is set up like this and it's got extra stuff, not just the absolute value bar. Bars like isolated by themselves, like number 1. You're basically going to want to get that left side to look more like number 1, how number 1 started. Okay, where it's just an absolute value bar isolated by itself. So that's actually what we're going to do for number 2 here. The first thing is isolate that absolute value. So first thing I'm going to do is subtract 2 from both sides. So you're going to have negative 5 absolute value bars, W minus 7 absolute value bar. Minusing 2 from both sides, you're going to have a 15 here. All right, from here I'm going to divide both sides by negative 5. So you're going to have something like this. Okay. Now, looking at this, that orange step that I have, you'll notice it actually looks really similar to number 1. Okay, it's got the absolute value bars isolated. It's equal to a positive value so that we can actually solve this out. Now from here, we're going to split it again to W minus 7 is equal to positive 3, as well as W minus 7 is equal to negative 3. So you have the positive version and the negative version, just like we talked about earlier. For this left part right here, I'm going to add 7 on both sides, and you're going to end up with W is equal to 10. For this other one, I'm going to add 7 on both sides, and you're going to get W is equal to 4. So we have 10 and we have 4 as the possible answers. Just like before, we're going to make sure that we check our work on this. So if I plug in 10 on this, we're going to get 3 for this part, times negative 5 is negative 15, plus 2 is negative 13, so the 10 checks out. We're going to do the same thing by plugging in the 4 for W, so that's going to be negative 3, absolute value of negative 3 is 3. Again, times negative 5 is 15. Negative 15, I'm sorry. Plus 2 is negative 13. So both answers actually check out. So that's how we know this is the right answer for this one. 10 and 4. All right, onward we go. Number 3. So again, you want to isolate those absolute value bars on that one side, but we still have this plus 9 here. So the first thing we're going to do is actually just add 9 on both sides. And you're going to be left with the absolute value of 5 minus 2/3 y is equal to 17. Again, once it's isolated, you're going to split it up into 5 minus 2/3 y is equal to positive 17, and 5 minus 2/3 y is equal to negative 17. And again, you're splitting this up because anything in the absolute value bars, as long as it's positive 17 or negative 17, you're going to get 17 out of it. Because the positive is going to stay positive, the negative is going to turn positive. So that's why we have that positive version and that negative version that you have to solve out for. All right, from here, I am going to subtract 5 on both sides for both of these equations, actually. So you're going to have negative 2/3 y is equal to 12. Then I'm going to do the same thing over here. You're going to have negative 2/3 y is equal to negative 22. Okay, kind of ran out of room here, but the equations are kind of simple, so I'm just going to put an arrow up here for this one. We're going to multiply both sides by 3 and then divide by 2. So if I multiply both sides by 3, I get 36 on the right, then divide by negative 2. for that. So you multiply by 3, you get 36 divided by negative 2 is negative 18. So you have y is equal to negative 18 for that first one. For the other one, same kind of thing. I'm going to multiply both sides by 3. You'll get negative 66 when you multiply that negative 22 by 3. Divide that by 2, you're going to get positive 33. And those are your two answers. Just for the sake of the video, I'm going to let you just go ahead and check those yourself, but these actually are the answers. So I'm just going to move on. And just for clarity's sake, this is the one that gets to the 33. All right, now number 4 is a little bit different because it's just set equal to 0. Now there's not a positive 0 and a negative 0 or anything like that. So for this one, all you really have to do is worry about this inner part being equal to 0 because the absolute value of 0 is 0. So I'm just going to take that inner part and set it equal to 0. Add 7 on both sides, divide by 2, and you're left with 7 over 2 is your final answer. If you check that out, it will work as well. And again, please don't forget to make sure that you're doing the problems before I am. So again, pausing the video, doing the problems, and then playing the video definitely helps. Let's see here, this one. Now this one's equal to a negative 5, but there is no way you can have a negative if there's an absolute value. So whenever you see this, you need to, a light bulb should be going off in your head. There is absolutely no solution because you cannot get a negative out of an absolute value. That is impossible. So the answer for this one would just be no solution. Now, say you did work this out and you didn't notice the negative and you messed that up. This is where checking your work really comes into play, because if you try to check your work on this, you'll notice that it doesn't work. So even if you forgot that absolute values can't be negative and you try to solve this problem out all the way, as soon as you check your work, you're going to hit a roadblock and realize, oops, this isn't the answer, and you'd realize that it was no solution. But that is the answer for this one. All right, this one. Now this one is weird. We have the absolute value of 2x plus 7 equal to the absolute value of x minus 1. It's like an absolute value set equal to an absolute value. Kind of a little tricky, but I'm just going to kind of show you the how not to get tricked on this. Basically, all you need to do is worry about both of them being positive. So make an equation where they're both positive. Something like that. And now you might be thinking, oh, and then the other one is making them both negative. The problem with the making them both negative is it wouldn't work, because if I made like both of these negative now, all I have to do is divide both sides by negative 1, and I end up back to where I just started. So you want to make both of them positive, and then you also want to make one of them negative. Okay, in this case, I'm just going to make the second one negative. It doesn't really matter which one you do, if it's the first or the second, but for the first part, both positive. The second part, one positive, one negative. And again, it doesn't actually matter. You can move the negative sign to the left or the right side of the equation. You're going to get the same answer regardless. But just make sure you understand that. Again, because the absolute value, if the inner part of it is negative, then you can solve it. And then it would still work out because it ends up being positive at the end. So it's similar to the other ones that we did. We have a positive version on the right of the right side of the equation. In this one, we have a negative version as well. So positive side, negative side. Same kind of rules that we were following for the other ones though. Let's solve this out. We're going to subtract x on both sides. So you're going to have x plus 7 equals negative 1. Subtract both sides by 7, and you're going to have x is equal to negative 8. The next one, I'm going to distribute everything over here first. So you're going to have negative x plus 1, just to kind of simplify things out there. I'm going to add x on both sides. You're going to get 3x plus 7 is equal to 1. We're going to subtract 1 on both sides, and you're going to get 3x. You're going to subtract 7 on both sides, and you're going to have 3x equals negative 6. Divide both sides by 3, x equals negative 2. And those are the answers, but again, feel free to check those, making sure that they actually are right. So that is our last equations example for absolute value, where we are now going to move into the absolute value inequalities solving section of this. And it's the same kind of thing where you have to worry about a positive version and a negative version. Only with inequalities, it's a little bit different just because instead of equal signs, we have inequality symbols, less than, greater than, and so on. So it says, just as we did with absolute value equations, we'll solve absolute value inequalities by rewriting them as compound inequalities. Okay. When it's less than, your answer is going to look like this. I'm sorry, not your answer. The solution step that you're going to be doing is going to look like this. If it's greater than, it's going to look like this. So you're going to want to make sure that's in your notes. Make sure you memorize that. Make sure you understand the difference between the two. because you're going to need both cases for the problems that we're going to do. These ideas should make sense if you think about x representing a distance from 0. That bottom part, important idea, be on the lookout for equations and inequalities that are never true or always true. Usually you can spot these before you even start the solution process. We're going to do some examples just so that kind of makes more sense with that important idea. So definitely memorize what I highlighted there in the red and the orange. But we're going to do some examples so it kind of makes a little bit more sense. Because it's one thing to just kind of talk about this, but you kind of need to see it in action. So let's move on to the next part. All right, for number 7, it looks pretty similar to the problems we were doing before. Hopefully you noticed the little difference here, that there's a less than or equal to sign there. But same kind of rule applies with the absolute value, is we want to isolate that. So I'm going to multiply both sides by 4. So you're going to get 3x plus 2 is less than or equal to 4. Now, this is where it comes in handy to kind of memorize that thing I was telling you about before. When there's a less than in an absolute value like that, it needs to be between the positive and negative version of whatever number is on the right of that less than. So in this case, it's 4. So in other words, what I'm trying to get at is this should say 3x plus 2 is less than or equal to 4, but also you need that negative 4 is less than or equal to the 3x plus 2 on this. And the reason for this is because this part, I'm going to try to explain this the best I can. This part right here, it needs to be either 4 or negative 4, but it needs to be also less than it. So that means it needs to be between negative 4 and 4. For example, if what I highlighted there just came out to be, I don't know, negative 3, that would still work because negative 3, the absolute value of it is positive 3. 3 is less than or equal to 4. So you can just kind of think of what I highlighted yellow there. It has to be between negative 4 and 4 because once you do the absolute value, it will be less than or equal to 4. So that's kind of why I had to make that compound inequality. And that is an important concept to understand. Make sure you're always, solving without the absolute value because it's really hard to deal with it otherwise. It just makes the math a lot easier. Just make sure you get rid of it by rewriting it into a compound inequality. First thing we're going to do here is subtract 2 on each side. So negative 4 minus 2 is negative 6. 3x plus 2 minus 2 is just 3x. And then minus 2 right there to get that 2. Then we're going to divide each side by 3 to isolate that x. So you're going to have negative 2 is less than or equal to x, which is less than or equal to 2/3. Okay, and just like before, it's probably a good idea to actually test, pick a number between negative 2 and 2/3, like maybe 0. Throw a 0 into that original equation and you get 2 over 4, which is less than 1. So it kind of shows that it works. Okay. If you wanted to write this in, interval notation, it could be bracket negative 2, comma 2/3. Just as kind of a review from those previous units, previous sections that we went over. But either of these would be counted as the answer. But if the problem asks for a specific way of writing the answer, it's just good to kind of show those two. All right, onward to number 8. Similar kind of thing. Again, pause it, try to work it out, and then hit play. I'm going to keep going though. First thing, isolating that absolute value, I'm going to subtract 12 on both sides. End up with something like that. Divide both sides by negative 5. You're going to have r minus 4. The absolute value of that is, now this is actually going to flip because I divided by negative 5. So you're going to have r minus 4. The absolute value of that is less than 8. Now remember, if it's less than, you need to set up that compound inequality. Negative 8 is less than r minus 4, which is less than 8. Okay, from here, I'm going to add 4 to both sides. You're going to have negative 4 is less than r, which is less than 12. And that's actually the answer. I'm going to write an interval notation just for fun. And we have our answer. And again, make sure you check that. A good number to check probably between negative 4 and 12 is something like 0. Throw a 0 into that original one, you get negative 20 plus 12, which is negative 8, which is definitely greater than 28, negative 28. So that works great. All right, number 9. Solve for x. Now, this one, again, is less than. Similar to the stuff that we were doing before. But hopefully you notice that this can only be positive. So this value can only be positive. So could you imagine a positive value that is less than negative 5? So is there a positive value that's less than negative 5? And hopefully you realize, no, you can't have a positive value that's less than a negative. Because less than a negative is just more negatives. So you'll never have a positive value that is less than a negative. So whenever that happens, the answer would be no solution. Okay, so be aware of that when you're looking at that. Anytime you see an absolute value and then it yields something that's negative, usually it's a sign that there's going to be either no solution or infinitely many solutions, which we're going to show in a little bit. For example, if that was greater than -5, then x would be infinitely many solutions, because you can put anything in there for x and it's going to be greater than -5, because anything you put in there for x is going to be positive anyway. Okay, so just anytime there's a absolute value on one side and a negative in the other, just make sure you know it's going to be a special case, and you got to be extra vigilant to make sure your answer is right. Now, say you did actually try to solve this out, you would hit a roadblock when you're actually checking this and go, oh, my answer doesn't work. That means it's no solution. But number sense is important, and I just advise kind of looking at this and trying to figure it out from there. So anytime you have an isolated absolute value and a negative value on the other side, a red flag should be, being waved in your mind, or a light bulb should be going off in your mind. Something's going on here, and just get a little bit of thinking going on that. All right, this next one, solve for t. It's got that absolute value there, greater than 6. Okay, this one should work out because it's not negative, but it's greater than, so it's going to be a little bit different. First thing we're going to do is, actually, let me just show you this kind of a review. So whenever it's greater than, you're going to have something like this, where x is greater than p, or x is less than negative of that p value. So we're actually going to take that into account when solving that. And it kind of makes sense if you think about it. Like, whatever's in there, that 3 plus t over 2, it needs to be greater than 6. For sure it needs to be greater than 6. Because when you do the absolute value of that positive value that's greater than 6, it's going to be positive again, which is greater than 6. The other side, though, it could be less than, because, so this one can actually be less than -6. And the reason for this is because, imagine there was a -7. Imagine if this in here evaluated, what I'm highlighting in orange right there, what if that evaluated to -7? Then the absolute value would make it 7, which is greater than 6. So that's kind of why, the reason behind that red and orange step that I have there. We're going to multiply, I don't know, just to get rid of the fractions, I'm going to multiply everything. Well, I guess I don't need to multiply everything by 2, but yeah, just for fun, let's just do it. I'm going to multiply that by 2, that by 2, and that by 2. Subtract both sides by 6, and you get t is greater than 6. Do the same thing on the other one, multiply everything by 2, you get 6 plus t is less than -12. Subtract 6 on both sides, and you get t is less than -18. Now, one thing that I want you to notice on this is you can pick either of these. So you can pick 7, throw a 7 in for t, it will be greater than 6. So the right side checks out as an answer. The left side. The right side, the t is less than -18. Just think, I don't know, -20. Plug a -20 in for t here, and you get -10 plus 3 is -7. Absolute value of that is 7, which is greater than 6. So that also works out. Those are the two answers. Now, if you wanted to write this in interval notation, I'm just going to kind of do this off to the side here. You could say, so t is greater than 6. So 6 would be the smallest there. 6, comma, parentheses on this, because it's greater than. So that's t is greater than 6. And then the other one, -18. So you're going from -infinity to -18, and that would be the two answers. Now, it's probably best to, do it with the union, 6 to infinity. I'm going to kind of just delete this up here. Okay, so that would also serve as the answer, if you want to do it that way. Either or, it really depends on what the question is asking. If it says to do it as an inequality, then you'll need that highlighted purple, what I have there. And then if it just said do interval notation, you would want that pink step there. So hopefully that makes sense. All right, last one. First thing we're going to do is isolate that absolute value, just like before. So I'm going to add 2 to both sides. So now we have 3x plus 7, the absolute value of that, is greater than -3. Okay. Now, again, this is where I want you to kind of pause. There's an absolute value on one side, and it's isolated, and then there's a negative number on the other side. So a light bulb should be going off in your head. This is a special case. Let's do a little bit of thinking here. Okay, on the right side, your value is going to be some positive value. It's going to be some positive value, and then it says greater than -3. Well, every positive value is greater than -3. So whenever this happens, where there's a positive value and it's greater than some negative? The answer is, well, any number, negative infinity to positive infinity. You can plug any number in there that you want and it's going to work. Doesn't matter how big or small it is. If you throw 100 in there, it's going to be accurate. If you throw negative 1,000,000, if you throw 1, 2, 0, pi, whatever it is, every number is going to work. So we're just going to write in interval notation negative infinity to infinity for that. So pretty easy once you understand it, but definitely take the time to look at it, make sure it makes sense. If you are still not seeing it, make sure you just ask me and I'll try to explain it in some other way if possible. So anyway, that's a quick video lesson on the absolute value equations and inequalities. Went over what an absolute value is. We went over how to solve the equations with examples. Same with the inequalities, how to solve those with some examples. Hopefully that all made sense. And if you have any questions about anything else related to this concept, let me know.